Okay, there's something on your notes that wasn't on mine, so we're gonna do that too. Okay.
Bro.
Well, all of those that aren't with us today. Okay, cosine x equals 1 minus, this is all the evens, so 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, x to the 8th over 8 factorial, and so on. Okay? So that is cosine. Oh, what's Sam here?
That was Abigail's turn.
Yeah. E to the x. So this is 1 plus x. Ooh. All right, so remember,
So we're gonna have to multiply the terms.
yes. If I can just do substitution, right? E to the x is this.
Right.
So 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And that goes on, but I only need the first 4 terms, so I don't need to worry about putting all of it, okay? And that's multiplied by cosine. So I can substitute that. Okay, and that keeps going. When I multiply polynomials, I have to distribute, right? So I'm going to do 1 times 1. 1 times this is negative x squared over 2 factorial plus x to the 4th over 4 factorial. Now, do you think I'll need to go past that with just my 1 times this stuff? If I only need 4 non-zero terms?
No.
I probably am not going to need an x to the 6th.
No.
Okay, because I'll have an x squared, x cubed, x to the 4th, and a constant, right?
That
So
works
I'm going to
out.
go ahead and move on to this one. X times 1 is x. And then I have negative x cubed over 2 factorial.
So is that all you need? Like,
Well,
this is
we have to do the same, we have to keep going
oh,
because we have to combine our like terms.
right.
So x to the 5th over 4 factorial. Wait, what am I multiplying? Yeah, just x. Okay, x to the 5th over 4 factorial minus, I don't need an x to the 7th. I probably won't even need that.
Oh, okay.
Yeah, probably won't. Okay, x squared, unless things cancel out. So x squared over 2 factorial, which looks like some of it will. So plus x squared over 2 factorial. And then minus x to the 4th over 2 factorial times 2 factorial. Should I go out to the 6th? Because those will cancel.
It looks like we have 4 terms.
Well, the problem is the x squared over 2 factorials are canceled. So that's going to go away.
I mean, as long as you have
But then we have
4
one,
different degrees, you should be fine.
2, 4, 5 terms, right?
This is going to cancel with that one.
Why?
Mm.
2 factorial
That's
times
2
2 factorial is equal to 4 factorial?
Is it?
Yeah.
No.
Wow.
it's
Oh, not 4 factorial. Sorry, I was thinking
Just
4. Yeah. Okay, so those won't cancel. We're good there.
Okay.
Unless I get it somewhere else, but no, I won't. Okay.
Isn't that still 2 factorial? Wait,
2
no,
factorial is 2.
2.
It's just
So
2.
it would just.
No, you made me. I was like,
It's like,
how do we
wait, that doesn't make sense.
Okay, I'm not going to mess with that right now. We can always go back. And then the last one, we'll do this x cubed. Well, no, I need an x fourth too. Ugh, I was hoping we have to go out that far. Okay, x cubed over 3 factorial minus x to the 5th over 2 factorial times 3 factorial plus, that's gonna be x to the 7th. I'm not gonna mess with that. Okay. Now this one. X
Wait, why
to
do
the
you need
4th.
that one?
X to the 4th over 4 factorial?
Yeah. Because the x to the 3 doesn't cancel out because they have different factorials in the denominator.
We have the constant, we'll have x cubed, but we need that 4th non-zero. So I need my
what
x to
happened
the 4th.
X to the 5th?
Well, that would come after. I need x to the 4th before I use x to the 5th.
Okay. And that one.
That would be
will
my
cancel.
5th term.
Okay. So then. Alright, okay. I'm just gonna.
Actually, my 6th term.
No, my first fail.
Okay, so I have gotten all of my terms that would ever have an exponent of 4 or less. I got a couple of 5s in there, but I don't think we're going to use those. But if I multiply 4 by the x squared, that's going to be x to the 6th. And if I go to the next term here, then I'd have x to the 5th. So everything else is going to be bigger than a 4, right? We've exhausted everything that's 4 or less as far as exponents go. So let's start simplifying to make sure we have 4 non-zero terms. First one is obviously going to be our constant. Now let's go through and see if we have an x. I have one x right here. That's the only one.
And then the x squared over 2 factorial will cancel.
Yes, x squared over 2 factorial is negative here and positive here, so that becomes 0, and I don't have any other x squareds. So now I'm going to x cubed. I have x cubed over 2 factorial here, x cubed over 3 factorial here, and they're being subtracted. So x cubed over 3 factorial minus x cubed over 2 factorial,
Is that
x cubed over 6 minus x cubed over 2. So I'm going to
over 4?
multiply top and bottom by 3. So I end up
Oh,
with
right. No.
negative 2x cubed over 6 or negative x cubed over 3. How do they write it? Oh, they don't, because they don't have this. So we can write it however we want. So negative 1/3. I'm going to go ahead and reduce just because.
Wait, how does it? Oh, it's 2, 6. So 1 6.
So then I have negative x to the 4th over 2 times 2, which is 4. And then a positive x to the 4th over 4 times 3, which is 12 times 2, which is 24 times 1, so 24. Which means I need 6 here. So that's negative 5x to the 4th over 24. 1, 2, 3, 4. First 4 non-zero terms, and we can stop.
Yay!
Product rule isn't looking so bad anymore, is it?
I feel like they
We
would
could do
invent
product
something-
rule a bunch of times and make sure we're right.
I don't.
But the point is that if you have any combination of series, you can just treat them or substitute them essentially, just like we would any other function. If I have x or 2x here, e to the x would be the same, except this is going to be 2x. It's going to be 2x squared. It's going to be 2x cubed, whatever. And then if I'm multiplying them, I'm just multiplying these polynomials, but they go on forever. But they're not going to ask you to, like, obviously you can't write it out forever. So they'll usually ask you for the first so many terms, or you'll write the general term, and you can start establishing that pattern. I would make it as simple as possible. I would say, okay, what's the general term of this? I would just write that times the general term for cosine. Don't even worry about simplifying or anything. Just this one times this one, if you needed to do that. Okay, but just treat it like you would any other polynomial. Hannah, did you have a question?
No, I'm chilling.
All right.
I thought she had one too.